It's not that pretty, but that's okay. So on this one, if I make u equal tangent, and what is the derivative of tangent? Okay, let's go backward. Derivative of tangent is secant squared. So what should I make u equal to create a secant squared? Tangent. So let's write out tangent. And if you're thinking, well, this is not that pretty, it's okay. Trust me. So let's write on here u is equal to tangent of x. And then on here we get du is equal to secant squared of x. And I'm going to write it in the form that I had it right here. Squared dx. And let's go ahead and compare. What I have when I derived is all on there. So let's go ahead and rewrite our problem. Integral of, we have u du, because all of that was underlined was replaced with du. And let's write the understood one. What is one more of that number? So we have 1 over 2, u to the power of 2. And for this one, we need to add what? Add c. And at the very end, all I need is to plug in the u back in. So we have half of tangent of x, all squared plus c. Okay, was 10 our next one? All right, let's go to number 10. Okay, what is the first thing that we are going to do on number 10? Rewrite the fraction into a non-fraction. So let's write over on this corner. So that's going to give us the integral of x. X minus 1 to the negative 1/2, since we'll bring it to the top. And let's go ahead and circle the piece that's got to be our u is equal to. So off to my side, my u is equal to x minus 1. Du is equal to dx. Don't I have all of that already? X is missing. That was our Toko piece. That other kind of. So we need to solve for x right here. And when I solve for x, what do I get? U plus 1. So let's plug it in. So we have the following. We have the integral. X alone is u plus 1. And then we took our u substitution at negative 1/2 and du. Let's go ahead and distribute. When I distribute, what is my u to the power of what? 1/2 plus u to the negative 1/2. And we have du. So now let's do our fraction thing. When I integrate, I get 1 over. What's one more? 3 over 2. U to the 3 over 2. Plus, if I do one more right here, what do I get? 1/2. U to the 1/2. And what do I need at the very end? Plus c. Let's plug in the u back, which I get x minus 1 to 3/2 over 3/2. Plus another x minus 1 to the 1/2 over 1/2 plus a c. If you wanted, could I have written this one on the outside as 2/3 and just 2 and do the reciprocal already? You may, but I'm okay with this. All right, what number after 10 was it? 15. All right, Keith, let's read number 15, please. So plugging in the x equals 0 and y equals 0 will be at the very end to find the c value. But what is the first thing we are going to do to get rid of our fraction? Multiply by dx. So we get dy is equal to 2x of 3x squared plus 5 all cubed dx. And then to get rid of, or to make y by itself, we need to do what on both sides? We need to integrate. Divided by d. Yes, that kind of sounds right in algebra, right? So we have y is equal to, let's go ahead and integrate, or use our u substitution. So we know u is equal to 3x squared plus 5. And then du is equal to 6x dx. And when I compare, I see an x, I see a dx, so we're good. Let's divide it by 6. So then when I rewrite this, I'm going to go ahead and move the 2 into the front. How about we also move 1 over 6? Yes? And then we have integration of u cubed du. So any questions on how I have substitute that in? Good? Can I go ahead and simplify this right now? You can. So we have y is equal to, that's 1/3. So time to integrate. What is 1 more of the 3? 1 over 4, u to the 4 plus c. And when I plug it back in, not plug it back in, our final one, y is equal to, and go ahead and grab the calculator. So we have 1 over 12, and our u piece is 3x squared plus 5 to the 4th plus c. Now let's plug them in. Y is equal to 0, x is equal to 0. And it's going to look kind of messy, and that's okay. 1 over 12. Are y'all okay if I just kind of eliminate this and just write 0? Yeah? Does everyone go with that? Plus 5 to the power of 4 plus c. What is 5 to the power of 4? How many? Not 500. 625. So whoever said a lot, yeah, it is kind of a lot. So we know our c is equal to negative 625 over 12. So our final value, by plugging this in, when I do, I get y is equal to 1 over 12 of 3x squared plus 5 all to the 4th minus the a lot. There we go. All right. 20. Was that our 5th one? 20? All right. Max, put that away and let's read. Number 20.
Values of the continuous function f has several values of x. Estimate that using a trapezioid approximation 4 equals.
So we have 4 equal subintervals. So if I'm looking at 12 total, each interval must consist of how many? 3. So 0 to 3 to 6 to 9 to 12. For trapezoidal, we have to look for a base 1 plus base 2 divided by 2 times the height. In our case, our base 1 is my low, and then to the right is our base 2. So we have 0.14 plus 0.36 divided by 2. What do I multiply this by? 3. They're jumping by 3s. And let's do that 3 more times. So we have 0.36. What do I add on the other side of the second set? 0.74 divided by 2 times 3. And then I have 0.74 plus what? 1.46 divided by 2 times 3. And then our last piece, we have 1.46 plus 2.0 divided by 2 times 3. And notice it's a calculator portion, right? Let's type that in. I'm not done yet.
89.
89. 10.89. Was that our last one? All right.